Remember, if point A comma B belongs to S, then B comma A belongs to S's inverse. This means that if the graph of a relation includes the point AB, then the graph of its inverse includes the point BA. Example A, complete the table. Points on S, points on S inverse. So all we have to do is swap these coordinates. 1 comma negative 4, negative 3 comma negative 2, 3 comma 1, 5 comma 2, negative 1 comma 3. And now that we have all of our points for S inverse, let's go to the next slide and graph them out. Alright, so in red, we are going to graph point 1 comma negative 4 here. So that's the inverse of that point. In blue, negative 3 comma negative 2 there. Negative 2 comma negative 3. Alright, so this point is the inverse there. 3 comma 1 in green there. Alright, in orange, 5 comma 2. And in that color, what is that? We'll call it purple, I don't know. Negative 1 comma 3. So there it is. Alright, so we have the circle points, which are the points on S, and the x's, which are the inverse points on S inverse. And if we draw in our dashed diagonal here, you start to notice something. You see that the points in their inverses are symmetrical over the diagonal. The way to tell that is if we draw a little line from the point to its inverse point, we see it goes over the diagonal. This line is perpendicular to the diagonal, and the length from the point to the diagonal is equal on both sides. So these points are symmetrical over the diagonal. The graphs of S and S inverse are shown. Each pair of companion points, A comma B and B comma A, are positioned across the diagonal y equals x and equidistant from the diagonal. So like I said before, this length here is equal to this length here, this length here is equal to this length here, and so on. This symmetry with the diagonal is a property of a relation and its inverse relation. Summary. The graphical properties of a relation S and its inverse relation. If AB belongs to S, then BA belongs to S inverse. The line segment joining AB and B comma A is perpendicular to y equals x. The intersection of the line segment joining A comma B and B comma A and the diagonal y equals x bisects the line segment. So this length is equal to this length. Proof. The slope of the line joining A comma B and B comma A is b minus a over a minus b equals negative 1. The slope of the line y equals x is 1. The product of the slopes is negative 1. Negative 1 times 1 equals negative 1, making the lines perpendicular. To prove the midpoint, use the midpoint theorem. The midpoint is a plus b over 2, comma a plus b over 2, which lies on the line y equals x.